Hi everybody, we're going to do some maths. We're going to continue looking at short division, and this time we're going to have more of a focus on remainders. Now, if you have found it difficult throughout the week, I'm going to put up a separate video, and that's going to go through the basics of short division. So I suggest that you go and look at that video before moving on to remainders, just because we need to have a really strong understanding of basic short division before we can then move on. There's no point expanding when we need a really strong foundation in order to expand, is what I'm trying to say. So let's have a think about this word remainders. It's an odd word. It's a really odd word. But if we have a look at it, we can see within that word, we've got the word remain. So remain is what is left. So that's what we're looking at today. What is left? What doesn't fit nicely into a group? I'm going to start off with a really just quick knowledge base. I can't go to the next slide. Here are some missing number problems. Let's work them out. Pause the video. How quickly can you work them out? Okay, so we've got 55 divided by 5 equals 11. Well done. And what divided by 5 is 1,100. We can look at, to do that, we could do the inverse. We can multiply 1,100 by 5, and we get 5,500. And then we can take 550 divided by 50 is very similar. Well, it's pretty much the same as doing what we did at the top, but these are 10 times larger. So our answer is 11. So this is, take note of this. Some of you might be able to do this in your head, but I really want you to follow along with what we're doing here. Now, you're going to be asked in a minute to draw these questions out, so I'm going to demonstrate how to do this. So Eva has 13 straws. She wants to make them into triangles. How many triangles can she make? Now we know a triangle has 3 sides, so each triangle needs 3 sides. Now you can draw this out. You can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But what are we going to do with this? That is what is remaining. So this is going to be our remainder. We take our whole groups, look at these as groups. So we've got 4 whole groups and we've got 1 left over. So it's 4 remainder of 1. 4 whole groups, 4 triangles, and 1 left over, 1 straw left over. So what I want you to do is just pause the video and work these out. I want you to draw them out. So you've had a go. So hopefully you've got your 3 questions drawn out. Let's have a look and explore. So Tommy has 14 straws. He wants to make them into triangles. How many triangles can he make? We do 14 divided by 3, because there's 3 sides in the triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many triangles have we got? We've got 4 triangles with a remainder of 2. And we write that as 4 remainder 2. I see some people just trying to do 4, they might put 4.2. Now this decimal is different to a remainder of 2. And we're going to look at next week what we can do with our remainders, because we can express a remainder as a decimal, a fraction, or as a remainder. But today we're not worrying about that, we're just looking at how we're going to work with them. So we've got 4 remainder of 2. I want to see that R2. If there was a remainder of 1, it would be 4R1. So Dora has, she's got her 12 triangles, so her 12 straws down there, because it's 3 times 4 is 12. She's got 3 left over. Here we go, I'm going to put them in. So has she got any left over? So we've got 12 and our 3 is 15. No, she doesn't. There are no remainders in this one. She can make 1, 2, 3, 4, 5 whole triangles. Now, so Jack has 16. He has his 15, which is the 5, 10, 15, 3, 6, 9, 12, 15. And the 1, which is the 16. So how many can he make? What is this doing? 16 divided by 3 is 5, remainder of 1. If we look at this, 3 times 5 is 15, add our remainder of 1 is 16. So we know that must be correct. So well done if you got that. So, what I want you to do, write this calculation using a short division method. Don't start to work it out, just lay it out for us. It should look like that. Our next step is we are going to plot this number on our place value grid. Should look like this. You should have 5 thousands, 2 hundreds, 9 tens, and 1 1. And we are going to divide it into 4. Yeah, we're going to see how many groups of 4 we can make in here. How many groups of 4 can we make there? How many groups of 4? How many groups of 4? So in our first one, how many groups of 4? Have a go. How many 4s are in 5? There's 1. There's 1 group of 4. And that looks a little bit like that. So we can see our 1 group of 4. But we've got this left over. That's left over. We can't just ignore it. So what we can do is we can exchange this 1,000 for 10 hundreds, because saying 10 hundreds is the same as saying 1,000. And so we can cross that out and we can exchange that back into our hundreds. And now the way that that's represented over here is the remainder. So what didn't fit in a group goes and sits next to our number. This is telling me that there are 10 hundreds and then 2 hundreds. So in total there are 12 hundreds. Let's check this over here. 100, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hundreds. Okay, how many groups of 4 can we get in 12 or 1200? We can go 1, 2, 3. 3 times 4 is 12. So 3 times 400, because each of these is 1, 2, 3, 400, is 1200. So there's 3 of them. Now, how many groups of 4 can we have in our tens? So we've got 9 tens. So 4, 8, 12. I can't have 12 because that's too many. I don't have 12, I have 9. 4, 8, so that's 2. Remember what we do with our one that's left over? We exchange that for 10 ones. Now we've got 11 ones. We've got 10 ones plus the one that was already there. How many groups of 4 are in 10 ones? 1, 2, that's it. But we've got 3 left over. 3 that didn't quite fit into a group this time, because we need 4 groups. And these are our remainders, these ones here. I've got a pen. These ones here. These are our remainders. So we've got a remainder of 3. Well done if you managed to get this. If not, replay, just go back and watch it again. And we would write our answer like that. Remember, it is remainder 3, not 0.3. So, just looking at this question, do we think that this could be correct? 5,627 divided by 5 is going to be 1,126. Is it possible? One way we could look at this question is to do a bit of inverse. We can look at, because a lot of people find multiplication easier than division. What do we know about the 5 times table? What does every number in the 5 times table end in? We know that every number in the 5 times table ends in either a 0 or a 5. Does this number end in a 0 or a 5? No, so we know it's not in the 5 times table. So we know we can't divide it by 5. Have a think about what might our remainder be. So we know it's going to end in a 5 or a 0. Well done if you thought our remainder is possibly going to be 2. And those of you that have worked it out, we know that well spotted if there was a remainder of 2. So, here we've got a final question before I set you on your work. Pay attention with this one because you may spot some mistakes. There are 349 people at a wedding. They are sitting in tables in groups of 8. So there's 8 people on each table. How many tables do we need? So what I want you to do is write down the calculation. Well done if you put 348. So this is our dividend and this is our divisor. We're dividing by 8. So how many 8s go into 3? None, because it's too small. So what do I need to do? I need to exchange our 3 10s, so our 300s into 8. So here we go. 8's in 34. That is 8, 16, 24, 32. So there's 4 of them, and we've got 2 left over. And that 2 left over goes here, because we was on 8 times 4 is 32. We need to get to 34. We need an extra 2. 8 into 29 equals 3. 8 times 3 is 24. How many is left over? Remainder 5. So that means we need 43 tables. Have a think. Did you spot any mistakes in there? So we actually need 44 tables. Why would we need 44 tables? We just worked it out. It's 43 remainder 5. Because actually we've got 43 tables, but we've also got 5 people stood up. And we can't expect them at a wedding to be standing up for very long. No. So that comes, the point of that is looking at the context of the question. Sometimes we express it as a remainder, but then we need to be sensible and round that up. Not all the time, but in this context we do need to. Now here are our 3 our chili challenges. We have our 1 chili here. All of these questions relate to this beginning paragraph. Read the beginning paragraph up here. So the children have their sports day. They're all really excited. Teachers want to put them into teams. There are 79 children in the school. So what we're doing here, we're doing 79 divided by 3. 79 divided by 4. 79 divided by 6. 79 divided by 8. And then you need to read this last one and have a think about it. For our 2 chili, the same sorts of thing. All of these questions relate to a new total up here, to 362. So it's 362 divided by 3, 362 divided by 4, and then read the questions. For our 3 chili challenge, again, it's the same thing. 498 children divided by 3, divided by 4, divided by 6, divided by 8, and then work out the last 2. And if you're feeling incredibly confident, some of these questions coming up are very tricky, but I know there are a few people that will definitely give these a go. I've got some stretch questions here. Really think about the answer. If you think it's really easy, chances are it might be wrong. Think about ways that you can check your answers too. They are very challenging. So I really look forward to seeing what you can come up with. Enjoy it, but please, if you're struggling with this, go back and look at the other video.